How's it going, everybody? Wanted to throw a quick thank you out to everybody that has been watching the videos as of recently and things like that. I've gotten a lot of really positive feedback to including Nexus inside of the switching course that I'm putting together, and still working on putting that together. I've just been tied up with some things, and on your screen is actually what I've been tied up with. I've been trying to spend a couple days a week doing CCNP switch and throwing in some Nexus in there so that people that may not see Nexus, or may not know much about it, they can at least see what the CLI looks like and some pieces to it. But that's actually not what this video is about. I'm actually not going to be covering anything for CCNP, at least for Switch anyway. So, as most of you know, I'm studying for I'm in the service provider track, and so I'm studying for those technologies. You also might have seen that I put a video out for a good friend of mine. His name's Nick Russo. He put out a book. It's just shy of 3,000 pages, and it covers a lot of the hardcore service provider technologies. The more service provider centric things. So, like, what it doesn't cover, and I've read through the book quite a bit now, it doesn't cover OSPF and ISIS and BGP and basic MPLS. So he's assuming that you already know these areas and that you're looking for the more advanced topics, the expert level deep dives, things like that. So, which is what it covers. Things that are more specific to service provider. Like, he does a really good job of explaining how MPLS traffic engineering breaks down. So it takes him probably a good 10 pages to explain to you the process of how things are working and stuff like that, which is really, really helpful for somebody like me that doesn't know it as well. But one of the things that I'm working on now is all the layer 2 VPN technologies that are on the blueprint. Now, one of the things that I've found online through the Cisco Learning Network is they actually have a study group, which they have a study group for all the different tracks and at all the different levels, so CCNA, CCNP, etc. One of the things that I found was the program managers for the service provider CCIE program actively post, and I was like, oh, okay, this is cool. So as I was reading through the different posts that they had, there was a few things that they're talking about that they will be able to test on and things that they won't be testing on. So like, if I remember correctly, they're not going to be testing on PBB EVPN. So if you're not familiar with what that is, don't worry about it. It's one of those more or less know what it is. It's going to be more for the written exam. They might throw that in a little bit and have you maybe test it out. A lot of things aren't supported on iOS XR, which is where PBB EVPN would come into play. The syntax, I don't believe, is even available for the CSRs. So the XRV, actually, the funny thing about XRV, for any of you that are interested in knowing anything more about the SP track, is that XRV actually acts more like a route switch processor, which, if you're familiar with like the 6500 series switches, the supervisor module, basically that's what the XRV is. All it is a route switch processor, and it handles the control plane. There are some data plane features because it's supposed to be was supposed to be a virtual route reflector. Was its original design and purpose for being created. So one of the things that I was going through today, and I'll break out my pen pad here and I'll explain to you what I mean. So for those of you that are not familiar with the service provider technologies, as well as you might be familiar with, like, say, L2 VPN for MPLS and things like that. Inside of this very large service provider core, this is a single autonomous system. So basically, it means that all these routers are one BGP autonomous system. I'm not running BGP currently. I'm only running IGP plus LDP. So I'm basically running IS level 2 and a handful of routers, just so I can get some basic reachability in play. So one of the very, very, very basic L2 VPN deployment models is what they call any transport over MPLS. Now what that means is any transport means it could be Ethernet, it could be PPP, it could be HDLC, I mean, it really doesn't matter what the transport is, as long as the router can terminate it. So, like I said, Ethernet, PPP, HDLC, frame, relay, it really makes no difference. I believe even doing like a PPPoE for like DSL, for what they commonly refer to as remote access VPN. So, at any rate, the factor that we're running into now is the way that I got all this set up here is I've got currently 4 XRV and I've got 6 CSRs, right? So what I'm doing is the 5 routers in the you see over here are all service spreader core routers, and what I've done and I've been doing is taking one router and I've basically been throwing a bunch of VRFs on it, so that I'm not running. The premise behind that is so that, for instance, maybe you're running this at home in a very light capacity. Maybe you only got 16 gigs of RAM to work with. My goal is to keep the topologies small enough to allow someone that doesn't have the resources available to them that I do would still be able to follow along at home. So now granted, I've got 64 gigs of RAM I can play with. Not everybody has that. So I try to keep the topologies as small as I can to get the job done. Sometimes the topologies grow 24, 30 gigs. They don't usually get much beyond that. The point here is I take one router and I configure multiple VRFs. So right now, router 6 actually has 10 Ethernet interfaces on it. And what I can do is gig 1 is obviously going to be for any sub interfaces that I use, and then gig 2 through 10 will be used. That was a horrible. Gig 2 through 10 will be utilized for point-to-point, where I might need to go in and use the physical interface or the virtual interface without a sub interface attached to it to connect to one of these other routers. So what I'm doing, because everything is set up inside of ESXi, is I have to make sure that I have V switches. So I create a couple of V switches in ESXi, and what I do is I map a interface on this router to an interface on this router in the same V switch. And the thing that you have to do here is you have to enable equals promiscuous mode, and then you also have to allow all VLAN, so 4095. Now what I was running into here was I have a pseudowire. Now all pseudowire, for those of you that are not familiar with that term, a pseudowire is what is used to basically the terminology for basically bridging the layer 2 connectivity over the MPLS core from, oh, that's the wrong router, from R3 to R1. Now what I'm doing is I'm actually creating what they call an Xconnect. So basically it's a cross connect. So what the pseudowire does is, and what it's actually doing is it's creating what they call a targeted LDP session between R1 and R3. Now what do I mean by targeted? Targeted simply means that my label switch routers that I'm actually trying to forward the traffic back and forth between are not directly connected to each other. So R4 and R1 are considered to be directly attached labeled switch routers. So when they form the adjacency, they're directly connected. They go out in the link, they do LDP goes to 224.0.0.2, which is the all routers multicast, link local multicast. So that's how they form LDP adjacencies this way. Now, when R1 and R3 want to form an adjacency to set up the atom connection, you actually have to have a way for R3 to reach R1. And in my case here, let me go ahead and pull up my screen here. R1, if we look at this real quick, R1, if we do a show run interface gig 2, R1 does know how to get to router 3. If we do a trace route to 3.3.3.3, we source it off of 1.1.1.1 numerically, I can trace route to XR3, or I'm sorry, router 3's loopback. So I'm able to get to where I want to go. So then what I have to do is I have to do a show run pipe section PW. Let's see here. Let me do, no, I want to do, what is that called? A pseudowire. Pseudowire dash class pipe MPLS. There it is. So what I actually have done here is I went through and I created a pseudowire class called Atom, any transporter over MPLS. And then what I do is I tell it the encapsulation will be MPLS. So this guy right here is kind of like a template that it's the most basic configuration out there. Well, actually, there's one actually even easier than this one, but I'll talk about that here in a moment. The idea here is you create this pseudowire class and the atom, and then you have the encapsulation set the MPLS. Then what I do is I come underneath here and I type in I go underneath the interface and I type in encapsulation or Xconnect the remote peers loopback address. So in this case R1 to R3, it's 33323. I find a pseudowire ID. Basically, this is going to be the virtual circuit identification. And then think of this right here as the frame relay DELC, if you're familiar with that. Then you have the encapsulation as MPLS, and then you say the pseudowire class is going to be Atom. So if we go to if we go to global config and we type in interface gig 2, we type in Xconnect 3.3.3.3 question mark, and you type in 100. I can come in here and type in pseudowire class is Atom. So what I'm actually going to do is this is actually working. If we do a show Xconnect peer 3.3.3.3 pseudo or VCID 100 enter, I have the actual connection up and running. So R1 has a targeted LDP session between R1 and R3. If we go to XR or router 6, and I come in here and do a show IP OSPF neighbors, I have a peering. Now what I'm actually doing is on R6, we do a show IP interface brief. I have gig 2 and gig 3, and you might say, well, they're directly connected to each other. Au contraire, show run interface gig 2, they are actually in different VRFs. So R6 underscore 1 and R6 underscore 5 are two different routers because they're two different VRFs. But they are able to see each other over the LD layer 2 VPN, which is set up by the connection we have here. So what I'm actually going to do here is on R1 and R3, I'm going to go up here. I'm going to type in do show run interface gig 2, and I'm going to type in interface gig 2. I'm going to type in no. I'm going to pull this out. Now I don't all this extra configuration here, the encapsulation MPLS pseudowire class any Atom. I technically don't need to have this encapsulation MPLS. I'm actually cleaning up the configuration. So I'm actually going to type this in right here, and that should pull that out. It's actually going to break our circuit. So you're going to see on R6 that the adjacency will go down here momentarily. And R3, I'm going to do the same thing. So our targeted LDP session is now down. So I'm going to go to global config, interface gig 2, do show run interface gig 2, no, and pull this guy out. Alright, so there we have it. So now the connection is down. If we go back to R6, eventually our adjacency will go down, and there it goes. So the adjacency is now down. Now I've got it still running, so when it comes back up, you'll see that. If we go back over to R1, the simplest connection here, configuration is called Xconnect, and you do 3.3.3.3 100. The number could be anything, and then you type in encapsulation is MPLS, and then you would type in the pseudo, and you hit the enter key, right? That is the most basic configuration that there is. You hit the enter key, boom, it's done. Literally, that's it. And then give it about a minute, and then it'll come up, right? So I'm going to go ahead and just do that on both ends, just so we can see what this looks like. And we're going to type in Xconnect 1.1.1 100 encap MPLS. Alright, so that's going to get our connection. Now it does take a moment for it to come up, so be patient if it doesn't come up right away. We're going to do a show Xconnect peer 3.3.3.3 VCID 100. So right now it's down. That's okay though, because momentarily it will come back up, and then when it comes back up, because we do a show MPLS forwarding, right now there is right now it's in drop. So eventually this will turn to point, and then there will be a number that sits in the parentheses right here. There will be a number inside that. So as soon as this guy comes up, which around a minute, minute and a half, 2 minutes. So for those of you that you're like, oh my god, this is gonna take forever. If you know there's gonna be like a delay. Now, granted, this is not viral configuration. This is not a viral router. This is a just a raw image. Eventually the peering will come back out and you'll be able to bring that up. So it does take some time. So I'm actually hoping it comes up sooner than later. It actually will give you a log message when it does, that everything's working the way it needs to be. So okay, so things are taking a bit longer than I was just hoping they would. So I found out by actually looking at it that the Xconnect never actually cleared, so I just bounced it. If you do a clear Xconnect, if you do the peer and type in 3.3.3.3 and then you type in the BCID of 100 and clear it, it'll actually clear. So now if we do a show this, now the connection is up, right? So now if I go over to R6, we have our adjacency. So that means that OSPF is running. So if we do a show IP OSPF neighbor, just so you guys believe me, the peering is up. Now this is between R6 and 2 different VRFs. So the router sees themselves directly connected to each other. It's like a big switch in the sky. So what I'm going to do now is I'm actually going to come in here and I'm going to go to global config and I'm going to remove that config. So I'm going to show you there's several variations of this configuration. I just figured I'd throw a quick video and show you guys a couple different versions of it. So we type in do show run interface gig 2 and type in interface gig 2 no and pull this guy out. We'll go ahead and hard clear it so that you guys will see how that would look. So that brings the connection down. It's funny how the state information in the network stays, but it is what it is. So I'm going to type in do clear Xconnect what was that command again? I forgot. I did it over here. Clear all. Okay, we'll do it on that. Xconnect all. Yep, reprovision all Xconnects. So it's actually not going to come up, but that's okay, because I'm not too concerned about that. Do clear Xconnect all. Yep, that's fine. So now what I'm going to do is I'm going to type in do show run section sudo. Sorry, so I already have my basically my template, if you will, already set up. So what I need to type in now is I need to type in Xconnect underneath the interface. Xconnect 3.3.3.3 question mark. VCID is going to be 100. I'm going to use a pseudowire class of Atom. Hit the enter key. I'm going to do the same thing on the other side. I'm going to type in Xconnect. I'm going to type in 1.1.1.1, the pseudowire class, the VCID of 100, and then the pseudowire class of Atom. And that's all there should be. So what I'm going to do now is I'm going to come out of here and then momentarily do a show Xconnect peer 1.1.1.1 VCID 100. So it's down at the moment. So I'm going to do that. Remember that clear command we used? I'm just going to go ahead and I'm going to bounce it. And same thing on this side. I'm going to bounce the connection. Okay, there it goes up. Now it's so now it's up. We do a show to this guy. We should be up. We are up and running again. If we go back over to R6, now we're loaded again. So we come up here. That shows you that it's working the way that it should be. If we do a show IP route BRF R6_1, it's not actually going to show us anything because we're not actually advertising any routes. So if I was to place a loopback or some other interface inside of that same VRF, then you would see stuff come up. Another variation of this command is to do a show L2 VPN, And if you were to say service and type in the name of it, type in Atom and type service name is Atom and hit the enter key. No. What is that? There's another option, L2 Atom VC 100. No, VCID. No, wait, hold on. There's the show MPLS. Show MPLS L2 transport VC. There it is. So there's a few different ways of looking at it. At the end of the day, all that matters is R6 has an adjacency set up, and we have the peering set up the way that we need to. That's what I really wanted to show you guys. So now, just a couple more. I want to take just another minute of your time, since I know you guys are here because you like listening to me talk. In order for this all to work out, there's a couple things that really need to be understood here. The first thing is here is all these routers, like let's say R1 is acting as a PE device. What I've done is I created a bunch of, right in here, I create a bunch of V-switches. And what I do is I create a bunch of interfaces on router 1, which are going to act as attachment circuits for this connectivity type. So what I do is I go in and I create a bunch of Ethernet interfaces on the router. And then what I do is they're all physical interfaces, so they're all gig 2. There's no sub-interfaces associated to them. I place those individual interfaces inside of different V-switches in the network. So I make sure that if I'm connecting R1 to R6, that the appropriate interfaces on R1 and R6 are in the appropriate V-switch. Now, once that's been accomplished, so in this case here, I got network adapter 2 is R1 to R2. It's just a name that I created a while back. I know it's just a V-switch name. So then I go over to R6, I go open console, or I'm sorry, edit setting, and I make sure that the appropriate interface is inside that same V-switch, R1 to R2. Now, that's great. Now, that matters. But here's the thing. That's not going to make a bit of difference if you don't go back to your networking and go to that particular V-switch. So if we look in here, R1 to R2, if I click on adapter or properties of that particular V-switch, one of the major things that has to be working here is promiscuous mode. Promiscuous mode is going to allow two VMs to talk to each other, and if you don't have it set up, your routers won't be able to talk. So it's basically like having a VLAN. That's what I do. Promiscuous mode, I enable that. The other thing I do is at the V-switch level, so the actual port group, is I allow all 4095 VLANs. I do that, and that allows the individual routers, the virtual machines, to communicate with each other. Then once they're communicating with each other, that works out. Now, I was having a problem earlier where I couldn't peer. So like if I go in here and I type in ping VRF R6_1 to 172.16.100.65, I wasn't pinging before. Now I am. If I do as you can tell, I've got a quick ICMP ping or debug working. So if I do get a something coming in from that, then it would work the way that it needs to be. Now you might say, well, wait a minute, you've got the same subnet configured on the same router on two different interfaces. Well, you can do that. The thing is you just got to be careful because you don't want to get a loop built. So we do a show run interface gig 2. I have a VRF on that interface. Same thing with gig 3. I have a VRF on that interface. So if I go in here, for instance, I type in interface loopback 100, and so actually let's do loopback 61. We'll type in VRF forwarding is going to be R6_1. I type an IP address of, we're going to say that this guy is 10.1.100.61/24. We'll type an IP OSPF What is that config again? Do show run section OSPF. I have to be careful because I got to put this in the right right VRF. So I type in IP OSPF. This is R61, so this is going to be 1 area 0. Okay, so now I've done that. So now if we type in do show IP route or VRF R6_5, we have an OSPF route. Right, it's one way, but I can still get there. If I do a trace route to Control C, trace route to VRF R6_, this was 5, right? 5 to 10.1.100.61 numerically, it's going to be directly connected to that router. So even though I'm getting there, and you see the route propagating, that's the important portion of this whole setup here. It doesn't matter if the factual matter of it. And the other thing that I want to show you guys too real quick is if we do a packet capture in the middle here, we go to like router 4, and I come in here and I do a monitor capture 1, and we're going to say match any interface, or actually match any interface gig 1 dot, let's see here, I want to match 41 and 45. Well, what path is this guy taking actually? Trace route 3.3.3.3 from a source of 1.1.1.1 numerically. It is going 10, so it's going 41 to the 34. So I want to capture on those two interfaces, 1.34 both directions, as well as 41. So if we do a monitor capture 1 start, we go back over here, we do a show monitor capture 1 buffer detail, you're actually going to see OSPF going back and forth, and some LDP. So as you can see, there's traffic going back. There's some UDP. This guy right here would actually be the targeted LDP section. So now if I could export this, and the export command here, let me just go ahead and pull this up real quick for you. I went a little further into this demo than I planned on, but you know what? That's okay. Let me go to Open Console to this guy. Does this guy have all the stuff that I'm looking for? This guy should. I think actually let me go ahead. Yep, it looks like this guy's going to be the one. Yep. It's blown up. So let me, bear with me guys. I just want to double check something real quick. And move that out of the way. Is it this guy? Look where connection details. I don't think it is. Actually, cancel properties. No, I want to do configure advanced. Okay, it is. One of the things you can do, which is actually really cool, and I will go ahead and I will remote into this guy real quick. 99. You'll be able to see what I'm talking about here momentarily here. So I'm going to go ahead and pull up Wireshark. And which interface is that? Okay, connection. So you're going to see a bunch of details going back and forth, right? So what I'm going to do is I'm going to do a come back over here to this, and I'm going to do a ping between. I'm going to do that ping again, right? So now what I'm going to do is I'm going to be able to come in here and type in ICMP and you're going to see this ping going back and forth. Right, so you're going to have 61 going to 65. Now if I come in here and I do this, you're actually going to see a lot of stuff. So you're going to see the pseudo-wire control word, you're going to see the MPLS label, and you're actually going to see this. So here's the double header. So you have pseudo-wire, or the, actually let me zoom this out just a little bit. It's a little too much information up front. If you look at here, you're going to have the MPLS label 19, and then you're also going to have 24. So this right here is the transport label. This is actually getting you from point A to point B. This is the VPN label. Okay, and the reason I know that is because the bottom of stack bit is turned on right here. The bottom of stack label is always going to be there. So if we go back over here and we look at this from the command line, and we do a look at R1 and we do a show MPLS forwarding, you're going to see that 24 is our label value for that particular situation, right? So we have 24. If we go to router 4, we do a show MPLS forwarding, you're going to see that 19 brings it in, and it's going, it's a pop label. That's the direction it's going in. And if we look at 19's pop label, the reason for that is because it gets to router 3, and router 3, if we do a show MPLS forwarding, in the reverse direction. So if we go from the ping reply, this one right here, that's 24, 27. So this is going from 5 back to 1. If you look right here, that adds up because it's going from router 3 back towards router 1, and we have 27 and then 16. So 16 in this case would be XR, or would be router 4, and 16 is going to 3. So that does make sense. So it's actually working the way that it needs to be. And you can see, you won't actually see the other information in here because OSPF is completely, you won't see OSPF at all. And the reason for that is because of the fact that OSPF is only on the is only relevant to the customer's network. So you're actually passing the information through the control word, which really isn't doing a whole lot. It's the actual MPLS label values that is actually happening here. So MPLS is the one that's actually switching the traffic from, you know, the inbound PE to the egress PE, and that's how the traffic is being switched. So if you can pretty much figure that out as you go along. So anytime you have a double, a 2-label stack, that means that you're actually in the MPLS core. If you have a single label stack, that means that you're either you're popping a label or some other thing. And here you're popping the label because you have the bottom of the stack label. So in this case here, I am a ping request going from, let's see here, it's on the directly connected link, so it appears directly connected. So that's pretty much how it would break down. At that point in time, you're in pretty good shape. So, excuse me, everything's working out the way that it needs to be. That's what I wanted to show you guys. I hope that this was informative for you, and I want to thank you for viewing.